So this obviously you don't know how to sketch this, but it's okay. Let me just visualize this for you. When you plot the graph, it looks something like that. Okay. So what you want is actually on this curve here, you just want to find this tangent to this point and the normal. Okay. So what do we do? Actually, it's very simple lah. What you do is you just implicit differentiation. Okay. Plus 5y squared plus 9 equals 0. So differentiate with respect to x. So this will be this is your u, this is your v. Okay, same thing. So keep the one on the right, left, differentiate the one on the right, plus keep the one on the left, differentiate the one on the keep the one on the right, differentiate the one on the left, then minus off. Similarly, let me just label for you. Similarly, this is uv. So this is keep the one on the left, differentiate on the right, plus keep the one on the right, differentiate the one on the left, plus 10y dy dx. Differentiate 9 is just 0. This case here, you can 6 yx squared dy dx dx equals to 0. Okay, what I can do is I just make dy dx a subject. You just make dy dx a subject. Then dy dx will just be this guy here. It's the same thing as the secondary school concept. Exactly the same. What you need now is to find m tangent. M tangent is dy dx when x equals to minus 2, y equals to 1. Okay. So you just replace into your y. So this will be my 23/4. So m tangent is 23/4. M normal will be 1 over negative 1 over 23/4, which is negative 4 over 23. So equation of tangent will just be y minus y1 equals to the gradient x minus x1. This will give us 25/2. Y equals to 23/4 x plus 25/2. So if I plot this equation, you see that there's a tangent across this point here. This is a tangent. Obviously, equation of normal, you do the same thing, but the normal, you just y minus y1, which is 1. Then you just use the gradient of a normal, x minus x1. Of course, you can leave it like that. Same thing.